For today, we're going to take a look at the midpoint and distance formula. Let's first start out with the midpoint formula. So as you look at the screen right now, you're seeing a bunch of letters and numbers and subscripts and things of that nature. Well, the midpoint formula is very simple. We are given 2 points, and we need to find the point that is in between both of those points. So this formula, what it's basically having us do, and if you listen very carefully, it's going to be a lot easier to think of it like this than to try and memorize this long, nasty formula. If we were given the 2 points, x1, y1, x2, y2, basically just any 2 points, what we are taking is the average value of your x, and that's going to be your midpoint for your x. We are also taking the average y value, and that will be the y value for your midpoint. So I'm going to go ahead and leave this up for a second. If nothing else, just write this down on your notes, side piece of paper, something that you can look at and recall. Your worksheet today has quite a bit of midpoint formulas to take a look at. The next formula is the distance formula. The distance between the 2 points x1, y1, and x2, y2 is given in the formula below. Once again, take a second, write this down on some scrap paper, have it to the side of you as you go to do practice problems. I'll work out a midpoint and a distance formula in a few minutes, but for now, take a second and write this down. This next problem asks you to find the midpoint of these 2 points. If you look at your packet, your worksheet online, you'll see that this is actually number 4, so you'll get to practice. You'll get one out of the way too if you write this one down. So in order to find the midpoint, we need to take our x1 value, our y1 value, our x2 value, and our y2 value. You can go ahead and mark those like that. Sometimes it's easier to see what you're using, especially as you first begin with these. So for this problem, we have x1 plus x2 all over 2, and we have y1 plus y2 all over 2. And next step down, we'll go ahead and do the work for this. And finally, simplifying this would give me 2 comma negative. I suppose if we do think of this as a decimal, it would be easier to visualize. So negative 6.5. That would be your answer for that problem. The main thing to remember is just plug in your x1, y1, x2, y2 accordingly, and perform the operation. So once again, I have a problem from your worksheet. This is number 10. However, we are asked to find the distance between these 2 points. The formula is there in red. Now, just as before, if I go through and I label these x1, y1, x2, y2, it'll be a little bit easier for us to start learning these problems. So using the formula, I have the distance is equal to the square root of x2, which is 1, minus x1, which is negative 2, squared, plus y2 minus y1 squared. And I need to take the square root of all of that. Now, yes, I have a bunch of minus and negatives here, so those will turn into plus signs. And eventually, I will get d equals the square root of 3 squared plus 8 squared. This then works out to be d equals the square root of 9 plus 64, which then is d equals the square root of 73. And just to refer to a distance, it's sometimes easier to round. This would be about 8.544 units. So that would be your answer. Once again, just like midpoint, throw in these values, do the evaluation, get the calculations, and you'll be good to go. Now, one other thing I want to mention, if you're still writing this down, you have problems 12, 13, and 14 on your worksheet. And these problems ask you to find the distance between 2 points, and they give you the points on a graph. Well, simply put, they're just visually giving you the points. You need to just figure out what the coordinate of each point is, and then it would be a problem just like this number 10. Good luck.